All boxes with a square base, an open top, and a volume of 70 feet cubed have a surface area given by S of x equals x squared plus 280 over x, where x is the length of the sides of the base. Find the absolute minimum of the surface area function on the interval 0 to infinity. What are the dimensions of the box with minimum surface area? Okay, so first of all, we're given the function. First of all, we're given the volume. Okay, so let's think about the volume of a box. The volume of a box would be length times width times height, right? And that's going to be equal to 70 feet. Okay, given that it says it's a square base, okay, the length and the width are going to be the same. Okay, so we can call those two, let's call them x. Okay, so we have x times h equals 70 feet, which means x squared times h equals 70 feet. Okay, so that's the volume formula for our box. That'll come back later. We're also given that S of x is equal to x squared plus 280 over x. Okay, and we're asked to find the minimum. Okay, so since we're trying to find the minimum, we need to take the derivative to find the critical numbers. We're also given the open interval 0 to infinity, which, since it's an open interval, not a closed interval, we do not need to test the endpoints because there are no endpoints. It's an open interval. Okay, so let's take the derivative. So the derivative of S of x would be S prime of x is equal to 2x minus 280 over x squared. Okay, and then to find critical numbers, we set the derivative equal to 0. So 2x minus 280 over x squared equals 0. If we multiply everything by x squared, we get 2x cubed minus 280 equals 0. Divide by 2, so x cubed minus 140 equals 0. And then solve that by moving that over. X cubed equals 140. X is equal to the cube root of 140. Okay, and if you put that in your calculator, that's approximately equal to 5.192. Okay, so that gives us our critical number. Now we could take a look at the graph of this. If you graph this in your calculator, you'll notice that the graph of this original function here, S of x equals x squared plus 280 over x, it's going to basically look like this. Okay, so as I approach 0, it's going to infinity, and as I go out here towards infinity, the function is also approaching infinity. So this right here is our minimum, and that is where x is equal to the cube root of 140, or 5.192. Okay, so we have a minimum there. So we know x is equal to the cube root of 140. That's where we have a minimum. So what is the volume of the box? Or not the volume, what is the surface area of the box with those dimensions? So in order to figure that out, we just plug in the cube root of 140 into our original function. So we get, let's keep that separate because we'll come back to that in a minute, s of the cube root of 140 is equal to the cube root of 140 squared plus 280 over the cube root of 140. Okay, so I'll go ahead and put that into the calculator, show you how I'm going to do that. So if you have this kind of calculator, TI-84, you hit math, go down to where it says cube root, type in the 140. Okay, it says squared, so I hit the square button, plus 280 divided by, let's do that math, go down to the cube root again, 140 again, and hit enter, and we get that the surface area, the absolute minimum surface area that we have, is equal to 80.886, and that's feet squared, okay, because it's area. Okay, so that gives us that, but it also asks us what are the dimensions of the box. Okay, that's where this other formula comes in. This length times width times height equals 70 feet. Okay, so we know that the x value, we found that right here, we don't know the h value yet. Okay, so if we just plug in the x value right here, we get the cube root of 140 squared times h equals 70 feet. Okay, so that is this formula right here, the volume formula. We're using that. Okay, so it's going to end up being h is equal to 70 divided by the cube root of 140 squared. Okay, so we can type that in. 70 divided by cube root 140, close parentheses, squared, and you get 2.596. Okay, so your dimensions of the box, your length times your width times your height equals 70, is 5.192 times 5.192 times 2.596 equals 70. So these three, length, width, height, are your dimensions.